Okay, now we're gonna do the remaining part of the review that has to do with confidence intervals. 31. A survey of 700 non-fatal accidents showed that 143 involved faulty equipment. Find a point estimate for P. A point estimate for P is simply asking you to find the sample proportion. And the sample proportion is nothing but X over N. X is 143 and N is the sample size 700. So just divide 143 by 700. Number 32. A survey of 250 households showed 91 owed at least one snowblower. Find a point estimate for P. Same question. He wants P hat, and P hat is X over N, so will be 91 divided by 250. That will be 0.364. Number 33. Find the margin of error for the given values of C, sigma, and N. I will provide the formula. You don't need to memorize them. So E, the formula of the margin of error is YZ. I put here because he gave me sigma. When he gives you sigma, you have to work with the standard normal distribution. So it's Z. So E is ZC times sigma divided by square root of N. Sigma is 11.5, N is 120. All we need to find ZC. For 90%, you either can memorize those common values or you can use StatCrunch to find them. It's 1.645. And how do we do that using StatCrunch? Let me show you. You can use the normal calculator. You go in between. For confidence interval, it's always between, and you put the 0.90 right here. And it's going to give you 1.645. You can see. If it is a 95, I ask you to memorize them. It's 1.96. And if it is a 99%, it's 2.575 right here. Okay, so this is how we get those critical numbers. So if you go back, this is E, it's ZC times sigma divided by square root of N. So if you take 1.645, guys, 1.645 times sigma, which is 11.5, and divide by square root of what's N here, 120, you get 1.727. So that would be the margin of error. Next question, 34. A group of 49 randomly selected students has a mean X bar 22.4. Assume that the population standard deviation is 3.8. That's sigma. Once he gives you population standard deviation, then you must use Z distribution, then standard normal curve. Construct a 98% confidence interval for the population mean. So the mean is sample mean is 22.4, the standard deviation is 3.8, and the sample size is 49, and he wants a 98% confidence interval. So here's how you do it. Let's close this one right here. We don't need it. So you go to stat, Z stats, one sample with summary. Okay, let me just lower this a little bit so you can see what I'm doing. So sample mean, what is it? Again, is 22.4. The population standard deviation is 3.8. Sample size was 49 and the confidence level is 98%. And look, you have to select confidence level right here and put 0.98. Compute, sorry. And here is the confidence interval. The lower limit is the left endpoint of the interval and the upper limit is the right endpoint. So if you want to make a statement here, you say with 98% confidence, we can say that the true mean is between 21.14 and 23.66. This is how you interpret the interval. Next question, 34. A group of 49 randomly selected students has a mean age of 22.4. 35. The standard IQ test has a mean of 96 and a standard deviation of 14. We want to be 99% certain that we are within 4 IQ points of the true mean. Anything that comes after within, guys, is the margin of error. So E is 4. He wants the sample size. The formula for the sample size is N equal ZC times sigma divided by E quantity squared. If this is 99%, I just showed you guys that the critical number Z is 2.575. So you put 2.575, the standard deviation is 14 times 14 divided by 4. So, and then you must square this number. So we'll have 2.575 times 14. And then if you divide by 4, and then you need to square it. Okay. That will give me 81.225. So the sample size must be 82 or more for exercise number 35. Number 36, find the value of E. The margin of error is E. Confidence level is 95. N is 15 and S. He gives you S now. So you no longer can use the Z. You have to use T. And here's the formula. E equals TC times S divided by square root of N. S is 5.6. N is 15. All we need to find TC. And here's how you find. You can either use the table or you can use the calculator to find TC. What we need for the from the normal T calculator to find TC, you need N and confidence level. So here's how you do it, guys. Just go stat, calculators, T. What's the degrees of freedom? N is 15, so it's 15 minus 1, which is 14. Do between right here. And just put 95, 0.95. So TC is 2.145. Okay, so that's what TC is. So so in order, let's go. So 2.145. Let's go back now to the question. So I know T, 2.145. Let's do it together. Times S. What is S, guys? Here is 5.6. And then divide by square root of 15. So the answer is 3.10. The margin of error is 3.1. Number 37. In a random sample of 28 families, the average weekly food expense was 95.60 with a standard deviation of 22.50. He didn't say population standard deviation. You have to treat it as an S. Determine whether a normal distribution or a T distribution should be used or whether neither of these can be used to construct a confidence interval. Assume that the population is normally distributed. Since he says the population is normally distributed and he gave you the sample standard deviation, definitely you can use the T distribution here. It's not a question to find a confidence interval. It's ask you whether we should use Z or T here. 38. A random sample of 10 parking meters in a beach community showed the following incomes for a day. Assume the incomes are normally distributed. He wants a 95% confidence interval here. So let me just do that for you. So again, a random sample of 10 parking meters in a beach community. He's given us the values. So we have the data this time. And he wants a 95% confidence interval. First of all, you have to put the data in static crunch. And let me show you how I did that. I put him under variable for it. Just go to stat. T stat. He didn't give me population standard deviation. Usually when he give you a raw data set, it's T. One sample with data this time, not with summary. And just select the data. And we want a confidence level of 95%. Compute, that's it. As simple as that. And so the interval mean will be between 3.39 and 6.01. The conclusion will be with 95% confidence, we can say that the true mean income per parking meter is between $3.39 and $6.01. Okay, that's how you do it. When 440 junior college students were surveyed, 200 said that they have a passport. Construct a 95% confidence interval for the proportion of junior college students that have passport. Very straightforward. It's a proportion interval. You have the confidence level, you have X, the number of successes, which is 200, and you have N, which is the number of observation for 40. So let me show you how to do that in StatCrunch. You just go to Stat, Proportion Stats, one sample with summary. Let me just lower that so you can see the whole thing. Number of successes is 200. Number of observation, what is it? 400, 440. And he wants a 95% confidence level. That's it. Compute. You see, this is the lower limit and that's the upper limit. So you say with 95% confidence, we can say that the true proportion of junior students who have passports is between 40.8% and 50.1%. Okay, so again, with 95% confidence, you can say that the true proportion of junior students, college students who have passports is between 40.8%. I changed this one to a percent, and 50.1%. 40. A survey of 400 non-fatal accidents showed that 181 involved the use of cell phone. Construct 99% confidence interval for the population proportion of fatal accident involving of non-fatal accidents here. So please change that one. It should be non-fatal accidents. Non-fatal accidents involve the use of cell phones. So we have N is 400, X is 181, and we want a confidence level of 99%. Okay, so you go to Stat, Proportion Stats, one sample with summary. So number of successes is what? 181. Number of observation is 400. Let me just make sure. Yeah. And then confidence level, guys, is 99 this time. Make sure to change this one to 99. Compute. So you get lower limit and upper limit, and the conclusion will be with 99% confidence, we can say that the true proportion of accidents, non-fatal accidents involving the use of cell phone is between 38.8% and 51.7%. Okay, that's how you do it. Next question. 41. A pollster wishes to estimate the number of left-handed scientists. How large a sample is needed in order to be 95% confident that the sample proportion will not differ from the true proportion by no more than 6%. So this is now a sample size question, but about the proportion, and this is the formula that will be provided to you. The difference between the sample proportion and the true proportion is usually the margin of error. So he gives you the margin of error, guys. It's to be 6%, which is 0.06. A previous study indicates that the proportion of left-handed is 9%. That's the sample proportion, guys. So he gave it to us. If he doesn't give you the sample proportion, so if you didn't see this statement after, then you use 0.5, 0.5. But since he gives you p hat is 9%, then you have to use it. And q hat will be 100% minus 9 will be 91%. ZC, what is Z, guys, for 95% confidence of 1.96, and E is 0.06. So if you want to do that, let's do the math. So it will be 0.09 times 0.91 times, open parentheses now, and put 1.96 divided by E, which is 0.06, close parentheses, and then square it. So I get 87.39. And remember, you have to round up always to the next whole number. So the sample size needed is 88 or more. Okay. Number 42. Find the critical t-value that corresponds to 95% confidence interval and n is 16. You can do that in StatCrunch or you can use the table. So you go to Stat, Calculators, T calculator, between, always between, degrees of freedom. So if n is 16, then degrees of freedom is 15, and 95, oh, I need a between right there. And, oops. And I need to change this to 95. There you go. So T is 2.1314. If he gives you sample size 25, degrees of freedom will be 24. If he says 7, degrees of freedom will be 6. So you just put the degrees of freedom, you go to between, and you put the confidence level right here toward the right. Remember, this is reserved for probability, and the confidence level is a probability. Okay, it is the probability that the interval contains the mean if you do this interval so many times. Okay, so that's how you find the critical number, and you can use the table. For the table, you look up the degrees of freedom, you look up the confidence level. One is a vertical, one is a horizontal. Where the vertical and horizontal meet, you will get your value. Next question. 43. Suppose 90% confidence interval that mean turns out to be between 1000 and 2100. If this interval was based on a sample size of 25, explain what assumptions are necessary for this interval to be valid. Remember, guys, when the sample size is less than 30, you have to assume that the population is normally distributed. So that's what's missing here. We need to make an assumption that the original population is normally distributed or approximately normal. 44. Construct a 95% confidence interval for the population mean. Assume that the population has normal distribution. A sample of 20 part-time workers, so N is 20, has a mean annual earnings of 3,120, that's X bar, with a standard deviation 677, that's S. He did not say population standard deviation, so it's S. Find the 95% confidence interval. Okay, let's do it. So that we don't need the calculator anymore. I don't need this. So you go to Stat, T-stat, one sample with summary. Sample mean is 3,120. Sample standard deviation 677. Sample size is 20. And what's the confidence level? I forgot what the confidence level he asked for. 90%, not 90, 95%. Okay, so it's good. Compute. Here you go. So with 95% confidence, we can say that the true mean annual income for part-time workers is between $2,803 and $3,437. Next question. 45. Construct a 99% confidence interval for the population mean. Assume population has normal distribution. A group of 19, so N is 19, randomly selected employees has a mean of 22.4 with a standard deviation of 3.8. Again, guys, is not saying population standard deviation, so it is S. So mean is 22.4, the sample mean. The standard deviation is 3.8. Sample size is 19, and he wants 99% confidence interval. So we can do that here. Stat, T-stats, one sample with summary, 22.8. Sample size is 19. Standard deviation is 3.8. Sample size is 19. And the confidence level is 99. Okay, that's the interval. With 99% confidence, we can say that the true mean is between 20.29 and 25.31. Okay, next question. The grade point average for 10 randomly selected junior college students are listed below. Assume that the grade point average are normally distributed. He has to tell you that the population is normally distributed because the sample size is less than 30. Find a 98% confidence interval for the true mean grade point average. So we need to put him in StatCrunch, and then we can find the interval. Okay, so let me do that. So for exercise 46, he gave us the grade point average for 10 randomly selected students, and he wants a 98% confidence interval for the true mean. I put the data in StatCrunch already. So let me show you how we do this one. I put him under variable 5 right there. So you go to stat, tstat, one sample with data, not with summary, with data, variable 5. And he wants a 98% confidence. Don't forget, you need to change this one. And here you go. T, you see, it's T confidence interval, 1.55 and 3.53. So you can say with 98% confidence, we can say that the true mean GPA is between 1.55 and 3.53. Okay, next question. The number of wins in a season for 32 randomly selected professional football team are listed below. Construct a 90% confidence interval for the mean number of wins in a season. I put the data already in StatCrunch, and all we need, just to run the test. We need a 90% confidence interval, so I'll show you. You can see I put the data under variable 6, so you just go to stat, tstats, one sample with data, select variable 6. I'm gonna select variable 6, and we need 90% confidence interval. Sorry. So the interval mean is between 7.18 and 8.75. So you can say with 90% confidence, we can say that the true mean number of wins is between 7.18 and 8.75. Next question. 48. In a random sample of 60 dog owners enrolled in obedience training, it was determined that the mean amount of money spent per owner was. So N is 60 here. X bar is 109.33 per class, assuming that the population standard deviation of the amount spent per owner is $12. So guys, here he's given you the population standard deviation. You must use Z. Construct and interpret a 95% confidence interval for the true mean amount spent per owner for an obedience class. So it's going to be a Z-stat, it's going to be a Z-test, and we're just going to go and do that. Okay, so let me show you how to do it. You go to StatCrunch, stat, Z-stats, one sample with summary. Reduce this so we can see the whole thing. See, one sample Z summary. Okay, sample mean is 109.33, which is X bar, guys, X with the bar on top. Standard deviation, he says, assume the population standard deviation is $12. So that's sigma. and 60 is the sample size, and the confidence level he wants 95%, which is by default 95%. So compute, and lower limit is 106.29, upper limit is 112.37. You say with 95% confidence, we can say that the true amount, mean amount spent per owner for an obedience class is between $106 and $112. Next question. A doctor at a local hospital is interested in estimating the birth weight of infants. How large a sample must she select if she desires to be 90% confidence interval that her estimate is within 2 ounces of the true mean? So this is about the mean. There are two formulas, guys, for n, one for the mean and one for the proportion. So we're going to use the one for the mean, which is n equals ZC times sigma divided by E quantity squared. So E is 2. Anything that comes after within is the margin of error. And he says the population standard deviation should be a sigma here, guys, is 5. So, and 90%, what's ZC for 90%? 1.645. So if I do the math, guys, let me show you what the math will turn out to be. 1.645 times sigma, which is what, 5, and then divide by 2, and don't forget to square. We need to square it. So I got 16.9, so the minimum sample size is 17. Make sure to try the algebra, the math, guys, to come up with the same answer as I did. Last question. A researcher wishes to estimate the number of households with 2 cars. How large a sample is needed in order to be 95% confident that the sample proportion will not differ from the true proportion by no more than 5%? So this is about the proportion. This is the formula. If he doesn't give you p hat and q hat, you use 0.5. If he does later, then you use those values. Look what he says later. A previous study indicates that the proportion of households with 2 cars is 22%. So p hat is 22%, 0.22. Q hat, how did I get 0.78? It's 1 minus 0.22, which is 0.78. ZC for 95% confidence, guys, is 1.96. And E is 0.05 squared. And if we do the math, let's do it together. So you get 0.22 times 0.78 times, open parentheses, put 1.96, divide by 0.05, close parentheses, and square them. And I get 263.68. So the sample size, guys, should be 264 or more for the sample size. Before I conclude this video, let's say, guys, you didn't have this statement right here. How would you still solve this problem? It's the same formula, but instead of putting 0.22 and 0.78, you put 0.5, 0.5 right here. So it will be 0.5 times 0.5 times 1.96 divided by 0.05 squared, and then you will get the answer. That concludes the review for the confidence interval chapter questions.